Hello, hi everyone. Welcome to the Student Brand. This is our Siva sir. Welcome to everyone. Welcome students. Today we are going to discuss about current electricity. Current. Okay, electricity. Current electricity. So current electricity is nothing but the rate of flow, the rate of net charge flowing through unit flowing through area of cross section. Okay, so the net, so I equal to q by t, net charge flowing through unit cross section area. Okay, so that is called electric current. Okay, the net charge flowing through cross sectional area. Okay, the rate of flow of net charge through unit cross section area. Okay, so simply we can say I equal to q by t. So the flow of charge per unit time. So I equal to q by t. And one more thing, so we can say I equal to dq by dt. So this is the instantaneous current. Instantaneous current. Current at particular instant. Okay. So what is SI unit of current? Ampere. SI unit of charge? Coulomb. SI unit of time is second. Okay. So Q is the net charge. Q is the net charge flowing through unit cross section area per second. Okay. Simply we can say flow of charge per unit time. Simple word. Right? In simple sentence. And one more point. So SI unit of current is ampere, SI unit of charge is coulomb, SI unit of time is second. So 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area. Okay, so now point number 1. So the flow of charge can be obtained by multiplying constant current with the time interval. Okay, with a particular time interval. And the second one, if the current is given in the function of time, so t initial, t final, I dt. And the third one, the area under the graph. Okay, area under IT graph gives the flow of charge. I and T gives the area under I and T graph gives the flow of charge. I on, so time on, so then it will gives the okay flow of charge. Flow of charge. Understood or not? I hope it is very clear. I hope it is very clear. So this is about electric current. Electric current. Electric current. Electric current. So based on the magnitude and direction, current can be divided into two types based on the magnitude and direction. Based on the magnitude and direction, current can be divided into DC current and the second one is AC current. So direct current and alternative current. Direct current is nothing but, so the magnitude and direction does not change with the time. The current magnitude and direction does not change with the time, then that is called direct current. So sources, cell, battery and DC dynamo. And coming to AC current, So current whose magnitude and direction both will changes with respect to time. Okay, according to time. So both magnitude and direction changes. That is called AC current. AC dynamo. Understood or not? I hope it is very clear. I hope it is very clear. Is it clear? Understood or not? Yes. So current I equal to Q by T, the net charge, the rate of flow of net charge. Okay. So that is called electric current. I equal to dq by I equal to Q by T, that is net charge, average current. So you can see I equal to dq by dt, that is a instantaneous current. Instantaneous current. And coming to the next one, based on magnitude and direction, current can be divided into two types. One is direct current, another one is alternative current. Direct current example, cell, battery, DC dynamo. And coming to AC current, so both magnitude and direction changes with respect to time. Example, AC dynamo. Understood or not? So I hope it is very clear. I hope it is very clear, right? Now, so we'll discuss about one more. That is drift velocity and relaxation time. Drift velocity and relaxation time. Drift velocity and relaxation time. Okay, so it is meant by drift velocity. So when the electrons are moving in the conductor, it experiences some force, magnitude of force. Okay, when electrons are moving in the conductor, so I am taking, these are the electrons are moving in the conductor, it experiences force. It experiences force. Understood or not? Yes or no? Current will be moving opposite direction. So electrons Vd is moving in this direction. Okay, both electrons movement and current both are opposite to each other. Both are opposite to each other. Okay. Is it clear? Is it clear? So now, when electrons are moving in the conductor, it experiences force, magnitude of force. So that is F equal to EE, F equal to QE. Okay. So when magnitude of force acting on the electrons, it produces the acceleration, then electrons will move. Yes sir. Then F equal to MA. F equal to MA formula. So MA equal to EE or QE you can take. So A equal to E by M or else QE by M. So anything we can take. Okay. So when electrons are moving in the conductor, when electron is moving in the conductor, okay, so all electrons are moving in the same conductor, right? So in the other conductor in one direction. So in the forward direction only it is moving. Okay. So what happens? So when it is moving in a closed enclosure, in a closed conductor, so one electron will hit another electron, that electron will hit another electron. Yes or no? The average constant velocity is called drift velocity overall. So see, after hitting, so this velocity may change. So next electron may change, next electron may change, next electron may change. Overall, if you are taking constant velocity, the average constant velocity is called drift velocity. That is one point. And coming to the second point, so here one collision is there. So electrons are moving in the conductor. One electron will hit another electron. That electron will hit another electron. That electron will hit another electron. So keep on collision is taking place. Keep on bombardment taking place, right? Yes, sir. So here collision takes place. Again, immediately it won't take. It will take certain time, right? Yes, sir. So it will take certain time to reach to the next collision. Anyway, collision will take place definitely because electrons are moving in a conductor. Definitely. Definitely electrons are moving in a conductor. Definitely it experience force. Then that produces acceleration. Because of that reason, electron will move forward. Because of that reason, the one electron will hit another electron. So there is a collision. So collisions will take place. Maybe it does not takes place regular intervals, but it takes place random. Okay, no? So immediately at regular intervals it won't take. So after 5 minutes, after 10 minutes, after 9 minutes, it won't take place. Okay, so like our college, so classes will take place according to timings. Okay, 40 minutes or 45 minutes or 50 minutes after next, like that. It won't take place. It will take place randomly. Like our wish. Okay. So whenever we'll get interest, we'll read. Whenever we'll not get interest, we won't read. Okay. So regularly the collision will take place. It does not take place. Regularly it won't take place. Randomly it will take place. Okay, randomly. Collisions only, no? So an electron will hit another electron, another electron hit another. Okay, so one electron will hit another electron, that electron will hit another electron, like that. Keep on bombardment takes place, keep on collision takes place at random intervals, not at regular intervals. Okay, so the average time gap between one collision to the another collision are two successive collisions. So here a collision takes place, after that, after certain time. So we are not taking the time. Okay, we are taking so successive collisions. The average constant. Okay, the average time gap between the two successive collisions is called relaxation time. So denote with the tau. Okay, so denote with the tau. Normally time is there, right? T. Yes or no? T. Okay, so collisions will not take place regularly. It will take place at random, and the time gap between the two successive collisions, the average time gap between the two successive collisions. So here you can see these collisions will take immediate. Another collision it will take time. So overall, if you take the average constant, so the average time gap between the two successive collisions is called relaxation time. Okay, so I hope it is very clear. I hope it is very clear. Understood or not? So this is about drift velocity and relaxation time. Drift velocity and relaxation time. I hope it is very clear, right? Next one, current and drift velocity. Next, current and drift velocity. Current and drift velocity. So I am taking current and drift velocity. Current and drift velocity. Drift velocity. Current and drift velocity. So this is the conductor. This is the conductor. I am taking this the conductor. So electrons are moving, right? Electrons are moving in the conductor. So here, this area of the cross section, here. And this the length you can take L, and time, anyway it will take time. Now you can see here, so V equal to L by T, that is nothing but L equal to, so here drift velocity and change in interval. So in this particular volume only the electrons are moving, right? So volume equal to length into area. Length is nothing but Vd delta T into A. So, number of electrons per unit. Okay, electron density. So, in this volume, the electrons are present, right? So, coming to electron density, number of electrons present in the particular volume, number of electrons, the number of electrons if you are taking, so N into Vd A delta T. Okay, so charge equal to number of electrons N Vd A into delta T into E. Okay, so now current equal to delta Q by delta T, then NEAD VD delta T by delta T, then delta T get cancelled. Yes or no? Then current I equal to NEAVD. So this is the current, the relation between current and drift velocity. The relation between current and drift velocity. That is a relation. Relation between current and drift velocity. Okay, I hope it is very clear. Understood or not? Understood or not? Is it clear? Yes. Current and drift velocity. Current and drift velocity. Hi, Chandrakant. Okay. So I hope it is very clear. Next one. Current density. Current density. Current density NEAVD. NEAVD, right? Current density equal to so J equal to I by A. So NEAVD by A. So A get cancelled. Yes or no? So A get cancelled, NEVD. So that is a current density formula. Understood or not? Understood or not? I hope it is very clear. Oh, Chandrakant, welcome to the board. Welcome to the board of exams. Okay, done. Now, so I'll discuss. I hope it is very clear. So what we discussed till now? Electric current, drift velocity and relaxation time. And after that, current and drift velocity. Next one, resistance and resistivity. Drift velocity, resistance and resistivity. Resistance and resistivity. Resistance. So what is the resistance? Resistance is nothing but the phenomena of opposing the electric current. The phenomena of opposing the electric current is called resistance. The phenomena of opposing the electric current is called resistance. Okay. So now, so I'll discuss about resistance and resistivity. Here resistivity. Okay. So first one, resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the cross section. Resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the cross section. So resistance equal to L by A. So R equal to rho into L by A. Okay. So coming to here, rho equal to RA by L. Rho equal to RA by L. Now, so now SI unit of resistance is ohm and a symbol is symbol. And here, so you can, this is very important. Ohm meter square by meter. Meter get cancelled. SI unit is ohm meter. Okay, ohm meter. Ohm meter. So that is symbol is ohm meter. Okay. So resistance depends on temperature. Resistance depends on temperature. Here also resistivity depends on temperature. And coming to the next one, resistance depends on nature of the material. Nature of the material. Nature of the material. And here resistivity also depends on nature of the material. Nature of the material. Understood or not? I hope it is very clear. Just check once. Resistance and resistivity. Resistance and resistivity. Is it clear? I hope it is very clear. Check once. Check once. So resistance is directly proportional to length of the conductor. R is inversely proportional to area of the cross section. R is directly proportional to L by R equal to rho into L by A. SI unit of resistance is ohm. SI unit of resistivity is, so this is symbol. SI unit of resistance. And resistance depends on temperature. Resistance depends on nature of the material. And coming to here, resistivity is equal to resistance of the conductor per unit length and unit cross sectional area. So R equal to rho equal to RA by L. Okay. So rho equal to SI unit is very important. So this is SI unit ohm meter symbol. It depends on temperature and it depends on nature of the material. Nature of the material. Nature of the material. I hope it is very clear. This is about resistance and resistivity. Next one. Temperature dependence of resistance. Temperature dependence of resistance. Temperature dependence of resistance. Temperature dependence of resistance. Okay. So here you can observe. So 2 points I'll discuss. 2 points. When temperature increases, very important 2 points. When temperature increases, so temperature increases, resistance and resistivity. Coming to second one. First case, two situation will happen immediately. So in the conductor, So at the same time, when temperature increases, the free electrons in the conductor increases. At the same time, okay, so the movement of electrons increases. It moves, right? When temperature increases, automatically the electrons will move. So at that point, at that instant, if electrons are moving, then conductivity increases, resistance and resistivity decreases. So point number 1. And immediately the next point is, so if the electrons are moving with a greater amplitude, okay, so our ions of the material moves with a greater amplitude, what happens? Those electrons will move with a greater amplitude, then it will hit another electrons. Okay, so the electrons are there, free electrons, it will move very fast. Those electrons will hit another electron. Then collision will take place there itself. Okay, immediately bombardment, collisions will take place. Then collisions will take place, then what happens? Resistance and resistivity increases, conductivity decreases. Resistance and resistivity increases, then conductivity decreases. So two things are happening at a time. Okay, so I hope it is very clear. Understood or not? Is it clear? Is it clear? Yes. So now, so same, R is directly proportional to L. R is directly proportional to L. R is inversely proportional to area of the cross section. R is directly proportional to L. R is inversely proportional to area of the cross section. R is. So when temperature increases, resistance and resistivity also increases. And here one more point. When temperature increases, right? Length and area of the cross section also changes. Yes or no? Length and area of the cross section also changes, increases. Yes or no? But so those are very quite small, very less. That's why R is directly proportional to rho. Here alpha is the coefficient, temperature coefficient of resistance. Temperature coefficient of resistance. Okay. So how resistance and resistivity will be? Now here I am writing this side. R T equal to R naught plus 1 plus T naught. Then R T. So resistance at temperature T. Then initial resistance. So we can multiply. R naught plus R naught alpha into T minus T naught. So R T minus R naught equal to R naught into T minus T naught. Then alpha equal to R T minus R naught by R naught into T minus T naught. So same thing for resistivity also. Rho T equal to rho naught plus half into T minus T naught. Then rho T minus rho naught into alpha T minus T naught. Then alpha equal to rho T minus rho naught by rho naught into T minus T naught. Okay. So I hope it is very clear. Understood or not? This is about temperature dependence of resistance. So at the same time resistivity also. One check. So you can check once. Next one, Ohm's law. So next we will discuss about Ohm's law. Okay. So I request to everyone, I am doing this all efforts for you only to teach. Okay. So do encourage the channel, share the channel, support the channel, inform to everyone, ask your friends to join to the class, share to as much as possible, as many as possible. So do like, share and subscribe. Okay, so then only I can able to reach to the maximum number of students, and my efforts will reach to the maximum number of students. So that is what I want, because I'm doing so many like different types of teaching. So you can check right from channel, right from starting of the channel. So I'm doing all these different ideas for teaching purpose only. So with okay, with the different types of costumes I'm teaching. So just check the channel. So share to as many as possible. Inform to everyone. Okay. So next one. Next one, Ohm's law. Ohm's law. Ohm's law. So Ohm's law is nothing but the potential difference across the ends of the given metallic conductor V is directly proportional to I, V equal to IR. V is directly proportional to I, V equal to IR. So at constant temperature and physical conditions also same. Okay, so here you can observe. Okay. So now, so I am drawing the graph between V and I. Okay, if you are drawing the graph between V and I, you can check the graph. V on y-axis, I on x-axis. The graph is like this. It makes theta. Then tan theta equal to R. Slope. Okay. So now you can observe. So R equal to V by I. R equal to V by I. So here 2 points, ohmic conductors or ohmic circuits or ohmic materials. So second one is non-ohmic conductors, non-ohmic materials, non-ohmic conductors, non-ohmic materials. Yes or no? Right? So here you can observe slope is tan theta equal to R. Tan theta, sorry, visible, tan theta. Tan theta equal to R, that is slope. Okay. So what do you mean by ohmic conductor? The conductors which obey Ohm's law, those are called ohmic conductors. The conductor which does not obey Ohm's law, those are called non-ohmic conductors. For ohmic conductor, the graph is straight line. So starting from origin. For non-ohmic conductor, the graph is curve. So here you can observe this is the graph. V on y-axis, I on x-axis. The graph is curve. Okay. So I hope it is very clear. So here at this point, so this is V1 and I1 and here V2 and here is I2. Okay. So now you can see this is R1, R2. Even though for non-ohmic conductor, this is for ohmic conductors. Ohmic conductor, the graph is straight line starting from origin. And coming to here, non-ohmic conductors. This is for non-ohmic conductors. Non-ohmic conductors. So even though it does not apply, so it does not obey Ohm's law, but still, so R1 equal to V1 by I1, R2 equal to V2 by I2, but R1 is not equal to R2. Okay, so one check here, one check. Is it clear? So this is about temperature dependence of resistance and Ohm's law. Ohm's law. Okay. Is it clear? Ohm's law. Next one. So we'll discuss about electromotive force. After completion of Ohm's law, we'll discuss about electromotive force. Electromotive force. Electromotive force. EMF. Electromotive force. Sir, what is this electromotive force? So normally if you are taking resistor connected to the cell, okay, so if you connect the cell to the circuit, suppose you can take circuit, so positive charge will move from positive terminal to negative terminal automatically, we know that. Okay, positive charge will move from positive terminal to negative terminal, but so in the cell or battery, okay, so here positive charge will be coming here, right? So after that, okay, so from here to here it should move, right? Negative terminal to positive terminal, or lower terminal to, so low potential to high potential. So positive charge should move from low potential to high potential. The influence that makes the positive charge to move from low potential to high potential, or the force which is required to move the, or the work done to move positive charge from low potential to high potential, okay, or the influence. So everything it is called EMF, electromotive force. What is that? Electromotive force, EMF. Work done by the battery on the charge. So E equal to W by Q. E equal to W by Q. Normally positive charge will move from high potential to low potential. Okay, positive charge will move from high potential to low potential. That we know that. High potential to low potential. So when in the cell, so charge should move. Anyway, after coming here, again charge should move from low potential to high potential. Which one is doing? So who is doing that work? Yes or no? Battery. So the work done to bring unit positive charge from lower potential to high potential, negative terminal to positive terminal, that force is called electromotive force. Electromotive force, EMF, that is called E equal to W by Q. E equal to W by Q. Understood or not? Yes, that is the electromotive force. Clear? Right. Next one. Resistors are connected in series combination. And next, resistors are connected in parallel combination. Resistors are connected in series combination and resistors are connected in parallel combination. Resistors are resistors are connected in series combination. So resistors are connected in series combination. That is nothing but, so here I am taking 1, 2, 3. So 3 resistors. Okay, R1, R2 and R3. Now that is connected to the battery. So positive terminal, negative terminal, current is flowing, charge is flowing here. Across R1 I am connecting V1. Across R2 I am connecting V2. Across R3 I am connecting V3. Okay, positive terminal, negative terminal, positive terminal, negative terminal, current is flowing like here. Understood or not? So now we can see, so throughout the path current is same. Is equal to I1 equal to I2 equal to I3 equal to I. Yes or no? Then from Ohm's law V equal to IR. So potential difference is different. So Vs equal to V1 plus V2 plus V3. That is nothing but IRs equal to IR1 plus IR2 plus IR3. That is, you are taking I common, then I you are taking common R1 plus R2 plus R3. Then you can observe I get cancelled. Okay. So I am cancelling I. So RS equal to R1 plus R2 plus R3. RS equal to R1 plus R2 plus R3. If n number of resistors are connected in series combination, RS equal to NR. If n number of resistors are connected in series combination, RS equal to NR. I hope it is very clear. Understood or not? If n number of resistors are connected in series combination, RS equal to NR. Now if resistors are connected in parallel combination, what if resistors are connected in parallel combination? Resistors are connected in parallel combination. Resistors are connected in parallel combination. Resistors are connected in parallel combination. So what happens? Now you can see here. So here this is R1, R2 and R3. Across R1, R2, R3, so I am connecting potential difference V. So here across R1, I1, across R2, I2 and across R3, I3. Okay. So current is passing like this. Now here you can observe. So potential difference is same. Vp equal to V1 equal to V2 equal to V3 equal to V. From Ohm's law, V equal to IR. I equal to V by R. Yes or no? I equal to V by R. So now IP. IP equal to I1 plus I2 plus I3. That is nothing but V by Rp equal to V by R1 plus V by R2 plus V by R3. So I am taking V common. 1 by Rp equal to V I am taking common 1 by R1 plus 1 by R2 plus 1 by R3. So here I am cancelling BB. Then remaining 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. If n number of resistors are connected in parallel combination, 1 by Rp equal to n by R, Rp equal to R by n. Okay, I hope it is very clear. Just check once. So this is about resistors are connected in series combination and parallel combination. Okay. So next one, Kirchhoff laws. Normally, so many circuits we cannot able to or we can't able to, okay, so reduce into series and parallel. That time sometimes we can't able to identify whether it is in series or whether it is in parallel, and to solve that time we are using Kirchhoff laws. Okay, so in that there are two types, two laws, Kirchhoff laws, two laws. We'll discuss those two. Very important. Very important. Kirchhoff laws. Kirchhoff laws. One is junction law. Another one is loops law. Okay. So second one is loop law. Loops law. Simply we can say loop law. Loop law. Loop law. So coming to junction law. Junction law here, sum of all the currents, the algebraic sum of all the currents meeting at a junction is equal to 0. The algebraic sum of all the currents meeting at a junction equal to 0. Okay. And coming to the loop law, the algebraic sum of all the potential difference in a closed loop in a circuit is 0. Understood? So here, if you are taking like this, so this is a junction, I1 and I2 are moving towards the junction, and I3, I4 are moving away from the junction. Then I1 plus I2 equal to I1 plus I2 equal to I3 plus I4. Okay. I1 plus I2 equal to I3 plus I4. Now coming to loop law. Okay. Kirchhoff loop law. So you are moving through the source. like a cell. Okay, here we have to follow 3.4, so 4 point number 1. So cell A, B. So we have to decide the path. So positive terminal, negative terminal. Okay, so the EMF of this cell is negative when you are moving from A to B, because you are moving from positive to negative. So the EMF is negative. EMF is negative. So very important. And coming to the second one, so negative to positive. A, B. Now you can see, so negative terminal to positive terminal you are moving, right? Negative to positive, so EMF is positive. So you have to check the final. Okay, so to which position you are reaching. So here you can see you are moving from positive to negative. So EMF is negative. Here positive to, negative to positive. So EMF is positive. And coming to the resistor. So this is the resistor and the current is passing like this. So if you are taking the path A, B, if you are going along the path and at the same time along the current direction, so the IR term is negative. So potential. So your third one. Coming to the fourth one. Okay. So here you can see A, B. So current is moving like this. Resistance. So we are moving opposite direction. So opposite direction to the current. Then we'll get IR term is positive. So these 4 points you have to remember. Okay. So when you are doing loop law. So under junction law, the algebraic sum of all the currents meeting at a junction is equal to 0. Coming to loop law, so these are points. So you have to follow. This is about the Kirchhoff laws. So here one more, okay. So with one example, I will tell one thing. That is about internal resistance and potential difference. Internal resistance and potential difference. Internal resistance and potential difference. When electron is passing through the electrolyte, it experience resistance. Okay, in the cell, internal resistance will be there. Because of that, voltage drop will be there. Voltage drop. So normally, whatever you are considering the potential difference of the cell or battery, it is the EMF minus the potential drop, IR. V equal to E minus IR. So internal resistance will be there. When electron is passing through the electrolyte, it experiences resistance. Okay, so V equal to E minus EMF minus IR, current and resistance. And the next one is heating effect of electric current. We'll discuss. Heating effect of electric current. Heating effects of Effects of electric current. Electric current. Heating effects of electric current. Okay. So V equal to W by Q. W equal to V into Q. P equal to rate of doing work, that is VQ by T. We know Q by T is current I. Then P equal to V into Q by T is I. We know V equal to IR. Then P equal to IR into I. So then equal to I square R. I square R. Then you can take energy equal to P into T. That is nothing but I square RT. That is nothing but heat. The source of energy continuously gets dissipated entirely in the form of heat. The source of energy continuously gets dissipated entirely in the form of heat. That is called heating effect of electric current. It is also known as Joule's law of heating. It is also known as Joule's law of heating. Okay. So now we'll discuss about grouping of cells. Series and parallel. Normally resistors are connected in series. Resistors are connected in parallel. We discussed it, right? Resistors are connected in series. Resistors are connected in parallel, like that. Like that. So we'll discuss about grouping of cells. Grouping of cells. Okay. Grouping of cells. So cells are connected in series combination. Now cells are connected in series. Series combination. Series combination. You can take one internal resistance, again internal resistance, again internal resistance. Is it visible? I'll draw here. Here, this is a cell internal resistance, again cell, internal resistance, again cell, internal resistance. Then that is connected to the external resistance R. External resistance R. So E, R, E, R, E, R. Then it is external resistance. Current is passing like this. Okay. So here you can observe E and R of each cell is same. Okay. E and R of each cell is same. Then net EMF. Net EMF equal to NE, because this is connected in series. NE. And net internal resistance. Net internal resistance, that is nothing but NR. NR. Now total resistance. Total resistance. Total resistance equal to NR plus capital R. So this external resistance R. Now, so I equal to net EMF by total resistance. Total resistance. Okay, so that is nothing but NE by NR plus R. So that is I. So this is about cells are connected in series combination. Next, cells are connected in parallel combination. Okay, let's discuss about it. Cells are connected in parallel combination. Parallel combination. So now you can see still if resist cells are connected in parallel combination also still you can observe and R of each cell is same. Then net EMF equal to E because so those are connected in parallel combination. Net internal resistance that is nothing but R by N. Next, total resistance is nothing but R plus R by N. Then I equal to net EMF by total resistance. Then you'll get net EMF equal to E by R plus R by N. That is I in parallel combination. Okay. So is it clear? So if it is clear, let me know. Diagram went little bit different direction. Okay. So I hope it is very clear. So if you like the content, if you like the channel, so if you like my explanation, so if you like the content, if you like the channel, if you like my explanation, please do like, share and subscribe to Student the Brain. So thank you so much for joining and attending and listening my class. This is your sir. So if you want to get more conceptual videos, share to all your friends and click on bell icon. Okay, do subscribe. Then you'll get all these updates. So thank you so much. We'll see you in the next class with a different topic. So this is your sir signing off. Thank you.